So the last page of this section is just more equation solving, but we just want to review, all the pieces that you do to equations. We are going to work on example 2, but I need to scroll it so you can see it better. So I'm actually going to scroll it about like that, because I really want you to be able to see things. All right, so let's go through, and we know that the first thing we should do, and it says it over here to the side, is distribute. So 3 times 3x is 9x. Okay, and then 3 times negative 2 is negative 6. Then here we have 7 times 4x is 28x. 7 times 3 is 21, so that's fine. And then minus 31x off to the end because it wasn't inside the parentheses. Then we want to combine like terms. A lot of times I use the phrase simplify. Okay, so I put the like terms together. So 28x and negative 31x is negative 3x. Okay, and I hope you can see that. That says negative 3x. Okay, I know there's a glare right there. I was trying to work it out that way. Then we want to move the x term on the left side over here with the x term on the right side. So we want to add 3x to each side. That way it moves from the left side and comes over here to the right side. So if I add 3x here, I would get 12x altogether. So think of it as I'm saying plus 3x on that side and plus 3x on that side. They cancel here, but they combine right there. Okay? Now it's kind of like the other equations where we just move the 6 and then divide the 12. So we're going to add 6 to both sides. When I do that, we cancel out on the right. Again, it's a little tight for room, so I can't write it down as well. But we get 12x over here. If I add 6 to 21 over here, I get 27. Okay? Then we divide each side by that 12, because that's our coefficient. So if you divide both sides by 12, you get 27 over 12. But that reduces. They both divide by a 3. Okay, so if you divide them both by a 3, just so that the fraction is as small as possible, and I'll just rewrite this kind of as a big fraction. 27 divided by 3 is 9. 12 divided by 3 is 4. Okay, so the solution is 9/4. And that's a 9, okay? So then we want to check ourselves. So let's put 9/4 into every piece of that original equation, and the left side should be the same number as the right side. So if I put 9/4 in right here, I put 9/4 in right there, and 9/4 in right there. The numbers are going to look funny, but it actually will work, okay? So when we work out all of this inside the parentheses, you can use your calculator or you can multiply. I would just use a calculator. You get 19/4, I believe. Let me double check that. Yeah. Okay? And if you notice, it's got those little question marks just like I did before. So if you work all of this out into your calculator, you get the number 12. That one works out nicely. But then this is another fraction. 31 times 9/4 is a pretty big number. 279 over, is it 4? Yeah. Okay? So right now it looks pretty crazy, but we're still going to get the same thing on the left and the same thing on the right. Even though it's not a nice number, it still could be equal, okay? So 3 times 19/4 is 57/4. You just multiply those two numbers. And then when you put this into your calculator, 7 times 12, take away 279/4, you actually do get 57/4 again. So it does check out. It's just a little crazy that it checks out. We just might want to use our graphing calculator for that. Okay? All right, so that is this problem. So then the other two, I'll just write out. Remember, you want to check it just to make sure that we're on the right track. You might get fractions when you check, but that's okay. So we're going to do those. You might want a calculator handy because you might have some more fractions, or use your phone or whatever. Let me grab mine as well. All right, so let's go to the next problem. All right, so let's scroll to the next problem real quick. All right, hold on 1 second. All right, so this one you want to try it on your own. Don't forget that you do need to check, and I'll work it out so that you can make sure you're on the right track. So, all right, so it looks like it's 30, but don't forget to go off to the side and check. So let's go off to the side. Let's put 30 in for all of our x's. 4 times 30 minus 6 equals 3 times 30 plus 2. Okay? So now let's see, does that work out? Let's subtract that. You get 4 times 24. And you get 3 times 32. Okay, well 4 times 24 is a little bit bigger than, and it's a little bit smaller than 100. Let's see, my brain, I think it's 96 actually. So 4 times 24, yep, 96. So do these equal 3 times, this is easy, 3 times 30 is 90. 3 times 2 is 6. So we do get 96 for both of them. Okay? So that one wasn't too tough. Now we've got to go through the same type of thing for this last one. Let's distribute. Now just be careful when you distribute. It's a negative 2. So that's negative 2x, but negative 2 times negative 7 changes to plus 14. Okay? This one's a lot like the example above where you need to simplify before you start moving variables around. So we get 3x plus 12 equals, put these two together. Negative 2 minus 15 is negative 17. You have to be careful when you combine or simplify those like terms, okay? Now let's move the negative 17 over here. We're going to add it because the opposite of a negative is a positive. Now, I'm doing it, pardon me, horizontally because I don't have that much room. You could write it underneath, kind of like how I wrote those underneath, but negative 17 and positive 17 will cancel. But since I added 17 on this side, they actually combine. So that's 20x plus 12, and that equals 14. So now I just have a two-step equation. I'm probably going to have to go off to the side. So take away 12 from both sides. Oh, I don't need that equals. Okay, let me go off to the side here. That's 20x equals, that goes away, equals 2. So when you divide by 20, just like the other problem, you do get a fraction. They both divide by 2. So they both reduce down to 1/10. All right? Now, we do need to check it. I have run out of room, so I'm probably going to try and scroll a little bit to check this. I guess we could check over here on the side. So let's do the check. out here instead. So check. That makes it a little bit easier. That way, pardon me, we have some room. So wherever I see x, I want to put in 1/10. So 3 times a 10th plus 4 equals -2 times a 10th minus 7 minus 15 times 1/10. So instead of x, x, and x, I put in 1/10, 1/10, and 1/10. So it is going to look a little funny as we work it out, but we still should get the left side. Does it equal the right side? Okay. So 1/10 plus 4. I'm just going to make it a decimal because it makes it a little bit easier because that's an easy decimal. So that's 4.1. 1/10 minus 7 is also, I'm going to make that a decimal, -6.9. And I'm going to go ahead and make this a decimal. 15 times 1/10 is 1.5. That 1/10 just moves the decimal place over to 1.5. So now 3 times 4.1 is 12.3. And does that equal -2 times -6.9 minus 1.5? Okay, so what I did was I just put all 3 of these, I multiplied and subtracted all at one time, and it does equal. So we do know that it's right. And I know right now it seems like checking is so unnecessary, but we really are going to have to check our Algebra 2 work. So that's why we want to get in this habit of doing both. So that down the road when I talk about checking, it's not new. You guys are like, oh yeah, okay, we've got to check, and so you'll be able to catch on to some of those topics, some of those concepts that we're going to be doing in Algebra 2, okay? So that should be good. You should feel that was a good review of solving equations.